All right, everybody, today we're going to talk about chapter 5.2, exponential functions and their graphs. So I want to make sure, first of all, this is video 1. Make sure you're watching the videos in order and that either you've printed out the notes or that you have a piece of paper and you are writing this down. We will have a test over this later, so it's crucial for you to have your notes. All right, an exponential function is defined as anything of the form f of x equals a to the x, where x is an element of the real numbers, so x can be pretty much anything except for imaginary. A has to be positive, greater than 0, and a cannot equal 1. So it can be fractions and it can be numbers bigger than 1, but it can't be negatives and it can't be 1 exactly, because that just gives you a flat line. So something else important here is that a is called the base. It doesn't give any transformation, it just tells you what you're multiplying by every time. So in our first example, y equals 2 to the x, your base is equal to 2. Base is equal to 2. So I've already set up some numbers here for x and y, just kind of telling you, remember, all you're doing is plugging in x, so 2 to the negative 2. Well, to do that, a negative makes whatever you're looking at move to the bottom of the fraction bar, move to the other side of the fraction bar. So this gives me 1 over 2 squared, or 1/4. That's 0.25. If you do -1, 2 to the -1 is 1 over 2 to the first, and that's fine, that's 0.5. 2 to the 0 is always, anything to the 0 power is always 1. Easy question, don't miss it. 2 to the first is 2. Anything to the first power is itself. 2 to the second power is 4, and 2 to the third power is 8. So I'm going to go ahead and graph this. So here I have it graphed, and I want to point something out to you. Notice that this graph is very flat, and it actually gets closer and closer to 0, but never crosses or touch it. That tells me that there is an asymptote at y equals 0. That x-axis is y equals 0. So exponential functions will have asymptotes. They will always be horizontal asymptotes. Whether the graph lies above or below it depends on whether you've reflected it or not. I want to show you real quick how to put this in your calculator. Our calculator, and go to y equals. We will put in 2, and then the caret top right here, that's what we're going to be using, 2 to the x power, and graph that. There's our graph, and it matches, right? Also, remember, you can go to second table. Right here, you hit second graph, and there are the same ordered pairs that we got. So you can do either one of those things to help you. So now we're moving on to transformations. We have done transformations before, so I'm not going to spend a whole heck of a lot of time on them, but I will remind you what each thing does. So the first thing when we talk about transformations is you have to start with the parent graph. So the parent graph is always base to the x. So just like here, our parent function was 2 to the x. It's actually the same thing here. This 2 to the x is our base parent function. So we are going to start with the graph of y equals 2 to the x power. Some of your questions, your homework questions, will ask you what you start with, and that's how you figure that out. It's always just right here, 2 to the x power. Now always remember, the 2 does not do anything with our transformations. So remember, if there is a negative in front, right here, I added this if you're following along with the notes. If there is a negative in front, that tells you that there is a reflection over the x-axis. It's not right next to an x, so it's a change in y. Same thing with this 6. This is a change in y because it's not right next to the x. So you know it's vertical. It's a vertical either stretch or shrink. Vertical stretch or a vertical shrink. Now, depending on what that number is, tells you whether it's a stretch or shrink. If the number is bigger than 1, it's a stretch. If the number is in between 0 and 1, like a fraction, that means it's a shrink. So again, the 2 does nothing. It's just the base. This is our base. So now if there was a negative in front of the x right here, if there was a negative right there, that would be a reflection over the y-axis. But there's not. I just kind of wanted to point that out to you and remind you of that. So I'm going to kind of get rid of that negative for now. But if there was, so now you are reminded. This plus 3 is right next to the x. That means it's a change in x. Since it's a change in x, you have to remember that the change in x's are opposite signs. So this is, changes in x is either left or right. In this case, it's a plus 3, so it's opposite of what we think. So that means we're going to go left 3. In this case, they don't have parentheses around them, but they will always be in the exponent. And last but not least, we have a minus 4. It's not up in the exponent right next to the x, so it's a change in y. And they don't have opposite signs, so this is down 4. State the transformations and graph the following. Here, it's key to start with the graph, so you need to figure out what graph you're starting with and what we're transforming. Again, the graph you're starting with is just the base to the x, so in this case, it's just y equals 2 to the x power. Now, the minus 2 is in the exponent right next to the x, so that means it's a change in x. Changes in x are always opposite signs, so this tells me that the graph of y equals 2 to the x, we are going to move to the right 2. Now, you can use your calculator to graph them, or you can just take the graph that we used up here and shift it to the right 2. Either way works. So, pulling up my calculator, going to y equals, I have y equals 2 to the x. Now, make sure, I already have that in there. I'm just going to add the minus 2. Make sure you're adding that in the exponent. And if you have the old operating system, you'll have to put that in parentheses. But graphing that, take our graph, shift it to the right 2. If you want, you can look at the table. So looking at my table, I have 0, comma 0.25, 1, comma 1 half, 2, comma 1, 3, comma 2, and 4, comma 4. And 5, if you needed to, it'd go 5, comma 8. Now again, this is going to go steeper and steeper and steeper on the right, and it's going to get closer and closer and closer to 0 on the left. So we know our asymptote is still at y equals 0. Just pointing this out for later. It will never touch or cross 0, so we will never have a negative y value here. Now looking at the next example, we have y equals 3 to the x plus 1. So again, this is our original graph, 3 to the x. So we have a different base here. Our base is 3 this time instead of 2. The base is just the number that has the exponent of x on it. So you're starting with the graph of y equals 3 to the x now. Then the only different thing is the plus 1. That is a change in y since it's not right next to the x, so it's an up 1. So the 3 to the x is just a little bit steeper and skinnier than 2 to the x, and we're going to take that graph and shift it up 1. So again, graph it, go to y equals, clear this out. We want 3 to the x power. Now make sure you arrow to the right to make sure that you are not writing in the exponent anymore. So we want to arrow to the right, see how it bumped it down, plus 1. We're going to go ahead and graph that. This is what our graph should look like. And go to the table. So I have negative 1, comma 1.3. I have 0, comma 2, 1, comma 4, and 3, comma 10. So here's my graph. I know that I'm going to get closer and closer, but never touch or cross 1 here, because what happens is that plus 1 took that asymptote of y equals 0 and shifted it up 1. So I know for sure my asymptote and the entire graph has shifted up 1. So in this case, I have an asymptote at y equals 1. And the graph will never fall below or touch 1. All right, last example is your turn. Here, what I wanted to point out to you first is that we are starting with this graph of 2 to the x. That negative tells you something different. That is a transformation. So go ahead and figure out what the negative does, the plus 4, and graph it. All right, here is our graph, and the negative in front means it's a reflection of the x because the y's are changing. And the plus 4 at the end means you're going to move up 4. Now, again, that means that your asymptote moves up 4 as well. So here, this is the asymptote at y equals 4. And in this case, since it's reflected, our graph lives below. So that means we will go all the way up closer and closer and closer to 4, but we will never touch or cross and go above 4.